Hi everybody, hope you're doing okay, and these are the examples for constant rule and then your power rule. So these are going to be the first, 6 problems from today's notes. All right, so here's the first thing I want to be sure and write down is the actual way that the power rule works. So if you can recall, the n gets multiplied by the coefficient in front, and then we are subtracting 1 from that power. Now, the first couple of problems where it says constant rule is, if it's a constant, if you recall how I said that the slope of a horizontal line is 0, well, these are both, let's just go ahead and write that as what it is. So the derivative of y with respect to x, that one's also going to be 0. Okay, moving on to the more power rule examples. So here we have the power of 5, and if you guys can recall, this is a function related to s in terms of s. There's the derivative of the function s. Our input is a t, so it's the derivative with respect to t. Now again, that's going to be part of the expectation of how to write these answers. So what are we doing? We have the power of 5. We're going to multiply by what's in front, and if you think of what's in front there, it's actually the number 1. When there's nothing in front of the variable, the coefficient is 1. And then from the 5, the rule says to subtract 1. So our derivative, and we're going to be sure and use this notation, is going to be 5t to the 4. And for that problem, that's what you need to do to take the derivative. For problem number 2, what we have to do is get rid of the radical and turn around and write it as far as a exponent or a power. So if you recall, remember that has a 2 and that has a 1. So that turns around and converts to the fraction 1 over 2. So in order to find this derivative, we're multiplying that by the coefficient in front, which is a 1, and we are subtracting 1. So we would have the derivative of y with respect to x, multiply that front, that coefficient by the 1/2, we end up with 1/2. X to the 1/2 minus 1 is negative 1/2. Let's do that little fraction mental math practice. 1/2 minus 1. What is minus 1 in terms of a denominator of 2? 2 over 2. What is 1 over 2 minus 2 over 2? Negative 1 over 2. Okay, so be sure to be able to do some of that mental math with fractions. All right, so continuing on. What do we have here? If you recall, I always want you to have positive powers or exponents. Well, that doesn't quite look like. All right, let's try that again. Positive exponents. And remember, exponents and the word power are the same thing. So in order to make this a positive exponent, it gets moved across the fraction bar and becomes positive. So what we have is 1/2, 1 over x to the 1/2. What's happening between those? They are being multiplied. So the more efficient mathematical communication way to write that is 1 over 2x to the 1/2. There's one more thing we could do. We could actually write it with the radical. All right, that's number 2. Let's go ahead and do number 3. So if you recall this notation, this basically was saying that that part is your function. So we could write this as our function, x to the 4/3. What is it asking us to do? Remember, we're going to have a 1 there. We are multiplying the power to the coefficient, and then we're subtracting 1. So the derivative, I'm just going to go ahead and write this in terms of prime. So we're going to have 4/3 x. Here's our mental math fraction again. 4/3 minus 1. What is that? 3/3. What do we end up with? 1/3. So, to finish writing this more mathematically, communicating more, or just more simplified, we would write this